My primary area of work is doing network analysis as a consultant, and that often has also to do with IT security. So we have a small team of 4 people who do network analysis together as a team, and very often that is helpful because doing network analysis all alone is not really a good idea usually, because you get an idea what the problem is like, and then you don't have anyone who's challenging you, which happens in our team right away. I mean, when I find a problem in a trace file and I say, this is the big problem the customer is looking for for half a year, then one of my team members, like Chris, who's sitting there, will instantly jump up and say, no, it can't be because. And in that moment, I have to defend myself why I think this is the problem. And if I can do it, he will at some point give in. Usually it takes about at least an hour. Sometimes it's faster. And if he gives in, we are getting closer to the solution. If he wins, I did something wrong. That is why I usually always encourage people, if you're doing network analysis, do it as a team if you can. If you have somebody else who's doing it, do it with them. And the funny thing about this is when I'm teaching Wireshark classes back home in Europe, very often the students in the hands-on practice exercises sit there like in school, typing and being quiet and not there to look right and left. And I always tell them in the first exercise, guys, this is not school. Talk. Discuss. If you found something, tell it to the next guy. Maybe he agrees with you, maybe he doesn't. And you get there a lot faster because, to be honest, network analysis is about being fast when finding a problem. It's not like, hey, I can spend a month on looking at a trace file. Yeah, if you can do that, or if you have to do that, all right. But usually it's better if you can say, well, I looked at this trace for 5 minutes and I know what the problem is. That was actually the case about a month ago. The customer sent me a trace line and said, we can't figure out why this isn't working. And I took a look at the trace line and said, after 5 minutes, I think this, we didn't even invoice it because I don't invoice 5 minutes. That's stupid. So he's happy because I found this problem. And he will ask me next time, and maybe then I will do a week or so on consulting. So that's pretty much the benefit of this. I mean, it was a basic thing. They had a telephone system. They wanted to do backups via FTP, and it worked for one location and not for 2 others. And it turned out they had some sort of ident daemon that was probed and didn't get through, and so the FTP connection didn't work. And on the side where it worked, there was no ident probe. So it was basically like 5 minutes looking at the trace. It's like, this is it. You see sin, FTP fails because of the ident D. This is not a case of what I'm showing you. So that is just a small example. All right, I also do virtualization. I'm a certified VMware instructor, great. I even got my certification for version 5 now, which is a lot harder. And maybe you've seen this sort of slide before yesterday, like when Hansang was talking. I was sitting in the back and I was like, this could be my slide. Because, and Chris next to me, he's like, yeah, all right, we can argue about where the column has to be, like the time column and whatever. But this is basically my default configuration. I have 3 time columns, like absolute time, relative time, delta time. Delta time always must be delta time displayed. It should and must not be delta time. Because it gives you funny readings. You try it out and you find out that the times you see are sometimes in regard to an invisible packet. And it looks much better than it actually is, or much worse otherwise. TCP default settings, stream reassembly, disable always. Because I would say, and we all do, if you're doing network analysis, you want to see the packets as they happen on the network, not like Wireshark wants to adjust it for you to be easily readable. Wireshark is using this setting like TCP stream reassembly to be able to reconstruct content for exporting of SMB objects and stuff like that. I don't need that if I'm not doing forensical work. That's the only time where I turn it on. So if you haven't seen it, my Wireshark should be somewhere. No, it isn't. All right. If you haven't seen it, it's a setting in the preferences. This is the long way to go. Usually I'm getting there quicker by taking a shortcut, but I have no trace loaded, so I have to go this way. Most people get confused by the amount of protocols in here. There's this one, allow subdissectors to reassemble TCP streams. This is usually checked. And you want to remove the check mark, because that way you will not allow Wireshark to fool you into thinking packets were in a different order than they actually were. This even will affect statistics reports, so you can have statistics that are completely different from what they actually are if this checkmark is set. If you remove it, it will look different. We have a case, or we have a trace file where you see, like, if you're looking at how much HTTP is there in a trace, you will see 13% with it being deactivated and 63% with it being turned on. So, or the other way around, I constantly forget. It's just messing with the statistics too. So I would advise to turn it off. The other thing is relative sequence numbers. It's easier to read, but sometimes you have to go absolute. Yeah? We will probably see why in one of the cases I have. Alright, so what else? Oh, my screen is usually a lot bigger. That's the other thing about network analysis. You can't have too much screen space. Yeah? You need at least 2 monitors, better 3 if you can put them on the desk. Color settings. Who uses the default color settings in Wireshark? Really? Okay, I get a migraine if I do. Usually what I would do, or what I did with Wireshark in the beginning, because I am sort of coming from the Sniffer Pro world where there was no color at all, I would go like, I disabled the color filters completely. About the color filters, if you have edited them, maybe you've seen this. If you, let me do a quick profile, new profile. Vanilla. Usually they're like this. Alright? I don't know who programmed this dialog, but I think it's very funny, because if I tell people remove all the color settings you have, yeah, everybody thinks like I can do it with the clear button. You click on it, nothing happens. And then you click into this, Control and A, and then you go delete. Now you can see what the clear button does. The clear button goes back to the default. Okay, for me, I don't know, I'm German, but for me clear means remove the stuff, not, I don't know. So this is some of the things where I'm always making fun of when I'm using Wireshark. Is Gerald here? Gerald? Anywhere? Okay, good. Okay, and another thing, which is, it's probably not something that has so much to do with the case files that I'm doing, but as you may have heard, the 1.8 release has a new default file format. Who has heard about that? Just a few, okay. It's called PCAP-NG. I think everybody knows PCAP. PCAP-NG means next generation PCAP file format. And if you've been to SharkFest last year, you will have seen the guy who invented PCAP apologize for it getting out too soon. And I agree with him, because the PCAP format is easy, but it's not very capable. PCAP-NG is a lot more capable of storing stuff, and I have put some of the advantages on the slide. You can capture multiple interfaces at the same time, so you have more than one network card and you can capture them, which is, well, some Linux guys will say, well, I could capture only any interface anyway, but PCAP-NG will allow you afterwards to find out on which interface which packet was, which you couldn't before, and PCAP can't save that. So you have to use PCAP-NG to be able to store it. You can put in file and frame comments. That is a feature that was requested, I think, for ages. And with PCAP-NG you can store it, finally, for the trace file and for the frames. You can also, and that is done automatically by Wireshark, save name resolution input to the file, which means that if you're saving a trace file, it will store which name is the name of the system belonging to a certain IP, so it will take your DNS info and write it to the file. So if you open it in a totally different location where you do not have access to the DNS server, it will still allow you to map the name to the IP address, which is pretty nice too. For me, it gives me a little headache, because that is another thing that you have to anonymize. If you're anonymizing trace files, PCAP-NG will be a challenge. And also, and that is one thing that I always complained about in my usually 1 week training sessions, is that Wireshark in the PCAP file format does not save the drop count number. So if you're capturing packets, you probably know that sometimes your capturing device is not fast enough to get it all. So it will drop packets for performance reasons, and it's very interesting to know that there were drops. Because if you look at a trace that has dropped packets, you will see like previous segment lost and stuff like this. And it could be that there was a packet loss. But if you know that there are drops, that is a very important info to know. And PCAP doesn't save that into the file. Yeah? So you stop capture, it will tell you drop packets something, and you save it, it's gone. It's just an info not kept. PCAP will store it for you. So you can reopen it, and you will see I had 0 drops and stuff like this. So basically, this slide is like preaching to you, use PCAP as soon as you can. The interesting thing about this is that if you're installing Wireshark 1.8 over your old Wireshark, it will keep the old setting, which is probably not using PCAP by default. So I will show you right quick where it is set. So you go to Edit, Preferences, and there's this capture thing. And here you have capture packets in PCAP format. That check mark must be in there. Yeah, otherwise you're not going to keep the info that you need. Okay. Enough of the boring stuff. Now the first case. This is a very, very small trace file, but it's very funny. I haven't seen something like this myself before this trace, and maybe none of you has. If you do, interesting. The scenario is like this. Actually, that is the whole system is mine. It belongs to me. I configure all this. I wrote the programs that run this, so I'm the one to blame. So if I'm cursing the programmer for being stupid afterwards, at the end of this case, you know who I'm cursing, myself. The user, that is usually me, has a laptop that runs a small program that is called Snarl. Maybe you've heard of Snarl and Growl. It's like a notification thing, and I use it for sending myself information from Nagios monitoring systems. So it tells me the server went down, the process went down. I have a little pop-up down in the corner, and there's a server that sends it to me. So whenever I turn on my PC, I will tell the server, here I am, if you have any messages, send it to me. And this is what the communication server does. It will send me any messages that I haven't seen yet. And it pulls it from a database. It's just, so if I come online, I will send to the communication server a message like, here I am, you can send me any message that I haven't seen yet. And it will connect back to me and push messages to me. That is basically the structure of this. And now for the trace file. Is that the right directory? Yeah. Okay, this is the trace. It looks very interesting because there's a lot of migraine-inducing colors here. So let me go back to my default. Maybe the font is a bit small. I use a very small font. It's a programmer's font that I can have as much information on my screen as possible. Maybe this is not so great for you to see, so I will change it back to something that is better readable. I don't know, what's the default? Courier is probably stupid, or I go back to the color thing and turn the colors off. Alright, here's a lot of stuff in there. You see some MySQL and that kind of things. Does anyone see anything that is very strange? It has nothing to do with the problem, but there's something here very strange, yeah? Negative times. Alright, where's that coming from? No idea. Well, I know where it's coming from, so I can tell you. Other things that are funny in this trace?
Unseen segment.
Unseen segment? Yeah. Okay. So maybe there were drops. Yeah. Unseen segment always means that something was acknowledged, but you didn't see the packet that was acknowledged. So this could be drops, maybe. Yeah. What else? Lots of gratuitous ops. Yeah? What's a gratuitous op? What's it good for? It's for refreshing MAC addresses, but more importantly, it's for detecting duplicate IPs. So whenever a station gets an IP address, it will ARP for it, like I will be using, which one is it? 192, 168, 122, I don't know, what is it? 253, this one. So this basically means I will be going to use that IP address. Does anybody else have it? If there's no answer, everything is fine. If it doesn't answer, uh-oh, I have a duplicate IP address, you probably know that the operating system will then open up a nice little dialog box telling you your IP address is duplicate. Windows does it at least. So what's so strange about this? They're all from the same IP address. It's always the same here, 253, 253, 253. And if you take a look at the timings, which are a little hard to read right now, so we can just filter for ARP and see what happens. You can see that even if they're in the negative, they're pretty close to each other, and it's always the same system doing that all the time. And that is not normal. Yeah? Speaking about patterns, you should know how often a gratuitous ARP is coming for an IP address, and it's usually right after the DHCP server gives you one IP address. You will just broadcast this one and say, well, I got this IP address, or I'm going to take it, am I going to use it? Not like this, and I have to tell you, I don't know why this system does this. I have no idea. It is a sniffer system that I am running in the data center, and for some reason it's doing this for half a year now. And I'm very lazy and I don't want to reinstall the Windows, so I just let it do this. I don't care. Yeah? It's a funny thing because I can use it in presentations like this for waking up the audience, do you see anything interesting in here? So if you ask me what's the reason for this, I have to tell you I don't know for sure, but I think it is because I exchanged the network cards in there, and somehow the operating system is a little confused because it now has a driver that is not used anymore with the same IP address, and it fights with itself by broadcasting, speaking to itself. And since it doesn't get an answer, well, it works. So we can ignore this one. I have a little helper here that tells me what I have to show. Well, back to my application. The application wasn't working at one point, so I was registering myself to my communication server, and it doesn't send me any messages. And I was like, I know that in the database there are messages that need to be sent to me, and I know that my system is registered. It should be sending messages to me. It doesn't. Why not? So I knew, well, this protocol is working on a certain TCP port. Yeah, so that is one thing that you usually need to have. You need to have the IP addresses of the systems involved if something is not working. And you should know which port it's using. Yeah, sometimes people can't tell you that, which is always the fun thing. Sometimes they can't even tell you where the servers are. I think I mentioned that story before. I did a SAP analysis in Germany once in a hospital, and they didn't know where the server is physically. It's like, okay, how are we going to capture this? Yeah, let's find it first. Yeah. That was quite a lot of fun. So, TCP.port is equal, should be this one. Alright, so we still have funny things here, like negative signs. Actually, this trace file was captured by capturing on two interfaces at the same time, which is allowed to do, or I'm allowed to do it because I know what I'm doing. I was capturing on my laptop locally. That is also something that you should only do if you know what you're doing. If you don't know what side effects this can have, capturing on the local machine, that is part of the problem, you should not do it. Yeah, speaking of CRC errors, too big frames, too small frames, stuff like that, that never is really happening, but it looks like this in the trail. And the other thing I was capturing was I was using the RPCAP, the remote PCAP capture daemon, to capture on the communication server at the same time. So now I have two captures being captured simultaneously. That only works with 1.8, or I was using 1.7 at the time, I think. We will be able to see it. And I have two capture interfaces going into my trace file, and since this box here, there's an RPCAP running locally, and what it does is it will pick up the frames from this machine and it will timestamp it locally and then send to me over the network. So I get timestamped frames from the remote machine, and I do my own timestamping for my own frames. Well, and now you know where the time difference is coming from. The system in the data center had a different system time than I did. And suddenly I have frames that are way out of line. So they have different times because of being different systems being captured into the same trace file. I don't know, who has seen RPCapD in action? Have you seen it before? Nobody? Alright.
Sends it via UDP or?
Pardon?
The remote capture sends it via...
I think it sends it via TCP. I filtered that out of the trace because it annoys a lot if you have the RPCapD in there as well. The default, I think, is TCP. I can show you the machine, I think, I hope. It depends on how well the connection over the Atlantic works back home to Germany. The ones who have been to my talks in the last 2 years already know this one. So this is in a 9,000 kilometer connection right now. And there's this process here called RPCapD. It's constantly running all the time. And I can use Wireshark to remotely connect to it. We will see if that works live. Sometimes it does, sometimes it doesn't. Here, I don't know, who has seen 1.8? The version 1.8? Okay. The others who haven't seen it are probably amazed by this dialog because it looks so strange. It's the new capture dialog in the new version. And here I can go and say manage interfaces. I have a remote interface. I edit 192.68.122. Port is 2002. And of course there's the password authentication. Let's see how long it takes. And now you see here are more network adapters for me to capture on. And I have them here somewhere. No, it doesn't show it. Yeah, that is some sort of bug. Usually they should show up, turn up here. So I would see my remote capture interfaces as well. And then I can capture with them. So that's what I did. And in here, since I now have two interfaces in the same trace file, the trace looks kind of strange because actually I'm having sort of duplicates in there. Yeah, everybody knows about duplicate frames and that they're messing up the analysis, so I have to remove them. But they're not complete duplicates because they're captured on a different layer 2 instance, so I can't just go edit cap and throw them out. But since I used pcap-ng, there's one cool thing now. I can go in here and say, well, like take the first frame. You will see here there's a new setting or a new value, interface ID. And as you probably all know, you can go and say apply as column. So now I have a new column somewhere, hopefully, there, that says interface ID. I put them to the front. And now you can see I have the ones with the minus times, they're on a different interface. They're on different on interface ID 1, and the others are on interface ID 0. So now I can go and say, well, this was the server. I want to know what the client does, so let's go here and say apply as filter, selected. Now I have only the communication of the client, and the server is, well, it's still there, but we don't see it right now. Okay, so now let's see what's happening here. I'm sending, if I now go to a conversation filter maybe, I could do that right away, but I wanted to show the IP, the interface ID. Here you see the server, 122.69, that's the server, is coming back to me. I'm the 101.111. It says, "Syn, hello Jasper, I've got a new message for you. I want to open a TCP connection with you." And my PC says, well, great, new messages, give them to me. And what is strange in the next packet? So what he's saying is, hello, I want to talk to you. Okay, I want to talk to you too. Shut up. Strange, okay. And then he comes back again and says, hello, I want to talk to you. All right, I'm here, just send something. Nothing happens, okay. Send something, hello, shut up. It's like, what is going on? Who has seen something like this? Like the one who's starting the communication, shutting it down right away. You did? Really? Do you know why that happened?
I've got a couple of different instances. I've got where users are on the same network as a cluster box are trying to get to, and we're doing load balancer for half of it.
Okay. All right. This is not a clustered solution. I'm happy that I have one server that's doing this. So this is only one machine. No cold standby, hot standby, whatever. Yeah?
You know, duplicate IP where the SYNAC makes it to the one who didn't request the send.
Once again?
What, duplicate IP? So there's another...
Yeah. It could be a duplicate IP. Yeah, that usually in this day and age would mean you have a duplicate MAC address, which is like the worst thing that can happen to you. Yeah. No, it's not a duplicate IP either. It's a stupid programmer. And you remember who was the programmer of the thing? That is me. Because I was writing the server instance of this thing, and it is actually a Windows service, so that I don't have to log into the server just to get it running. So it runs as soon as the server starts. And what I did in my code, and I can try to find I think I have the snippet of code extracted somewhere. Let's see if I can find it. This is the one code sample, this one. This is what I did. Yeah. So actually, if you're bugging me about this programming language, that is Delphi. So please don't hit me because it's not C or something. And what I did here is I said, well, snarl handler, snarl is a small program that is running on my machine. The connect timeout is 10. And I was thinking, well, it's 10 seconds. Good timeout, right? Guess what? It's 10 milliseconds. Basically, that means the server is like, hello Jasper, I want to talk to you. And if we look at the round-trip time for how long that takes, it's longer than 10 milliseconds. And my SYNAC gets back and he says, what do you want from me? I shut down the socket. So actually, this is a case of programmer didn't read the documentation of this thing, right? So that is the first case that I have, like shooting myself in the foot by not reading the programmer's guide the right way. So I fixed it, I put it back on, I think, 5,000 or 10,000 or something, and now it's working again. But that was a trace where I said, wait a minute, SYNAC, reset? What's that? Never happened to me before. And I found it really quickly because I knew that I had done the code change like a few hours before, and suddenly it didn't work, so I was just diffing the code that I had with the one that I wrote, and I saw, oh, you changed the connect timeout thing. So I looked into the documentation and I found out, well, it's 10 milliseconds. And since I was doing this over a VPN connection and not in a local LAN, it took so long that, well, I do the SYNAC and get the reset back.
So, sir, what was the unique identifier you were able to say where the target said, no, I'm not going to respond on a trace file? What led you to that? So where you said, you know, there he is, and here's 70, it says no.
This is the server coming to me, 122.69, going to me, which is 101.111, and I reply with, okay, go ahead, talk to me, and then it said no.
Yeah. How do you get that? Out of that line there, where does it say no?
In here, there's RST. RST means reset, and reset is a flag in the TCP header that everybody knows, hopefully, at some point, right here. And we used to, and that is the good old ages, to have reset as an indicator of something going horribly wrong. Until somebody started to say, well, let's just tear down a valid session with reset flags. I'm not looking at anyone, but some guys of the company are here. So, yeah.
If you ever use a Jasper printer, you find out that the normal action that printers take time to print, and they can't do a second print job while they're in action. So if you have a spooler, which of course is ready to send the second job immediately, the second connection will get an RST, indicating that the printer is not ready.
That is pretty rude.
That's what we want.
Okay. I've seen printers doing a Windows 0 kind of thing. So very often printable, like I have to spin up first, so Windows 0, and then you can continue. Okay, so that was the first case. Basically, what we could do now, if we wanted to, is go back and take a look at what the server is seeing at the same time. And you will see here that it's getting, well, just a second, I have to turn off this name resolution stuff that's so annoying. Okay. And where's the communication now? Down here somewhere.
Hey Jasper, can you do me a favor and hit that magnifying button way up on top? Because there's like no way we can get that font. I mean, I'm old.
Which button do you want me
So
to
like,
hit?
okay, so just under the help, where you turned off your colors, now go to your right. No, don't hit that.
I increased the font, okay.
Button bar, but there you go.
I increased the font.
Actually click.
Of course. Is that better?
Awesome, thank you. Appreciate
Okay,
it.
I can increase it. Did anybody?
Yeah, that's what I meant.
You know the reason why I don't use this? Has anybody used the zoom buttons before? Really used it in normal life? Because it's so funny. I was in a training class once, and I was like, "This is a zoom button," and then the student said, "How far does it zoom?" I don't know if you ever tried this, but I did it for 5 minutes. And I ended up with one character being like the whole screen being black. And I said, well, at least there's a way to go back there really quick. And then if that's funny, you should try zooming out, because that's quite good. Who can read this? I can't. Maybe I can, but you can. Okay. Yeah, well, alright. There's a reason why I always change the font, because this is sort of like, I don't know, erratic behavior. Alright, so where was I? I was looking at my server communication. My mouse is going crazy here. RTC and TCP.port equals 99.987. Here you can see SYN, SYNAC, reset, SYN, reset. So this is the server side. It's we're responding a lot quicker with the resets. Still, if you look at the times, they're hard to read because they're in the negative. But you can see here that it's taking too long for the client to get back to the server, so it shut down the port. And if the port's not open, you will get a reset. Yeah, so that's what happened here. Okay, so the next one, and I have no idea how much time I have left, but the next one is industrial TCP. Who has ever done network analysis on industrial TCP connections? Talking about Siemens remote control things that are doing the craziest stuff. Yeah, sometimes they have viruses attack those. You do? Okay.
They got crazy pretty well.
Yeah. Whenever a customer calls me about this Modbus stuff, I'm like, oh no, do I really have to? Because for me, the programmers of this industrial TCP stacks, they're like, okay, let's put in the stuff that we really need and leave out everything else. I don't care about RFCs. And that is one of the things that I had to look at. In this case, basically the customer wanted me to find out what is happening in the communication between a server and a Modbus device. That is basically a scenario where a server is talking to a small embedded system that is adjusting the operation of a huge cooling system. Basically, that is a company who is in the business of selling turkey, I think. So they have a huge building where they have all the meat being kept until it's shipped out. And the system is made in a way that when the building is only half full, the cooling system will not run on full power, because it will cost a lot of money for all the electrical bills that you have if you're cooling the system or the building down to crazy levels and it's almost empty. So they only need to have a big amount of Yeah, well, the cooling must be cranked up to the maximum only if the building is completely full with meat that needs to be cooled. And the problem was that this server that tells the cooling system how much it has to cool and how much it doesn't have to cool lost the connection every once in a while. And guess what the cooling system does when the server is not talking to it anymore? It goes for the fail-safe, and that means full power to the cooling system. So very often they had their whole building like minus whatever degrees Celsius, and it was not even half full. And it cost them, I think, a 6-digit number because of the cooling system cranking it without being necessary. So they wanted to know, why is the server losing the connection to this device? And I have no network diagram because it's basically a point-to-point connection, server talking to this device, and the network is chaotic. It's a level structure, no VLANs, no segmentation, no nothing. It's just tons of devices in the same layer 2 network. And the funny thing about this company is that they have other companies installing stuff for them, like new robots that help in dissecting the birds and that kind of stuff. And these companies, they put in new devices without asking the network administrator, and they're just pulling cables from the networking racks, like using any ports they find, and you find cables hanging from the walls and from the ceiling without any documentation, like, yeah, we had to do this on the weekend and you weren't here, so we just did it. So it looked like a bomb has gone off in their computing center. And well, that didn't help much, but that was a very chaotic network. So let's take a look at the traces. I have 2 of them. That is what they gave me, 2 traces, 24 megabytes and 16 megabytes. And they told me this is a capture together going over 1 hour of operation between 5 and 6 in the morning. And what I usually do if the traces are like this, okay, let me clear the filter first. If I get 2 traces that are, well, 2 parts of a whole, I usually merge them together first. As long as I know that Wireshark will be able to read it, because at some point it will crash if it's too big. But I will usually merge these together to be able to see it completely. Yeah, and that's what I'm going to do. How do you match trace files? Merge cap. Okay, you could do it from here as well, but somehow whenever I do it, the order of the trace files get messed up sometimes. So I usually go for the command line and do merge cap. Like this, I go to the trace files. In this case 2, and then I go merge cap minus W for writing a new file, merged.pcap, minus A because I want just to connect them to each other, like concatenate them, not go by timestamp or something. And now I tell it to go modbus 1 and modbus 2. And now we should have a new file, merged pcap, which is both files in one. Now I can open that one. It will take a while. All right, so I know that the communication, the customer told me, is between the 2 IPs that are in the first packet. So what I usually will do now is go for a conversation filter. With a big trace file, this will take a while because it has to go through all the frames. I tried putting it on an SSD, it's still not getting faster, so I think it's not a file reading issue, but something internally.
T-Shark it.
Yeah, I could T-Shark it, but I'm more of a GUI guy right now. So I have my communication here, and as you can see, it's pretty long. It's about, let's see, 24,000 frames. So one thing I would probably do in the beginning is go for tcp.analysis. Which one? Flags. All right. Who's using TCP analysis flags a lot? Just a few, okay? You need to do it more. Maybe it's too much work for you to type it in. Yeah, I don't know. If it is, who thinks this is too much work to type it? Nobody. You do, all right? Let's go and find a quicker way of doing this. So, preferences. And you see something new here, filter expressions. So let's say add expression is TCP analysis flags. And I call this, let's say, flags, exclamation mark. Okay, so now you see here I have a flags, exclamation mark button. I can click on it and I don't have to type. Yeah, so this is pretty nice. I found it by accident because whenever Gerald puts out a new version, I'm like looking, what has he done this time? And when I see something that I can't explain to myself, I try to figure out what it is, and this is one of the things. You can basically put a lot of buttons in your bar up there with filters you often do. You only have to click on them, and they're done for you right away. Okay, so yeah, I know that the communication is breaking at some point, so I have here some retransmissions, a lot of them actually. So something seems to be bad. And as we heard in the talk of Han-Sang already, retransmissions in itself, if they're not fast retransmissions, are not so funny because they take time. Actually, I want to know if a communication is broken at some point, so I would have to scroll through this, maybe, or I can look for a reset flag, because we already learned reset flags mean we want to stop something. So I could go for TCP flags reset. Is anyone else wondering why I have to write reset and not RST? Because it's SYN and ACK and that kind of stuff, but reset has to be written with more letters? I'm like, okay, it's open source, everybody can do what they want. So, let's see if there's a reset packet in there. Sorry for it taking so long, but the trace file is this big. And I wanted to give you the feeling of what I have to cope with every day when I do trace file analysis, which is basically waiting for stuff to happen. Alright, there's some resets in here. Well, okay, I still would need to filter on the IP addresses that I'm looking for, so this reset alone is not good enough. I have to find the communications first. Actually, what I did in this moment here is something that I very often do in the beginning when I don't know much about the trace file. If you don't know much about a trace file because it's not coming from your network, then you need to find a good way of getting the picture quicker than by just scrolling through packets and looking at them. Even if you're good at pattern detection, it will take a while when you're looking at like 362,000 packets. I mean, you could have an intern like scrolling through for you, but what I usually do is I go for the statistics, for example, like conversations. Everybody knows those, right? Conversation statistics. If you don't, write it down. So now we have this 505 TCP connections, but once again, this is not what I'm interested in because I already know the IP addresses that are part of this. So what I'm going to do is I filter back on this, and I don't know why this is not 10 entries long, it's now less than that, for whatever reason. And I need to find the first frame again. Somehow it got sorted in a different way. Come on, what's going on here? Ah, that's because I have the reset, right. I only want the first one, so I don't care. Okay, better. Now it's this one. Conversation filter, TCP, so I get an automatic filter that filters on both IPs and both ports. That's enough for me, and now I go to conversations. There are still 109 TCP connections, now limited to the display filter. That will tell the statistics to only show me conversations that have those IPs, which is kind of stupid because I wanted to see all the communications between those IPs, so I filtered wrong. I filtered on TCP connection. That is only one, of course. I want to see all between the two IPs, so what I need to do here is not go for, that's my mouse pointer, conversation filter TCP, which will only give me one connection between the two, but I need to go for conversation filter IP, and then I will see all of them. Alright, so we wait again. This is a good way to get a long talk over quicker, because now I can just wait, not say anything. Alright, come on. Good, so now where's my conversation statistics here? Stop limit. That's another trick. You can stop it when it's showing everything. You just stop it and then you're hitting the limit checkbox and it will start again and do what you want. So now that was one thing that I did at the customer side to get a feel for how much do these two systems talk to each other. And there's one interesting thing in here, because if you take a closer look, there's the colors that most people very often do not use, like relative start and duration. And it can tell you one thing right away, and that is the second communication starts right after the first has terminated. Yeah, you can see it. It says duration relative start from 0. It goes 1400 seconds almost, and then the next one starts right after that. Relative start is at 1400 something, and duration is a lot shorter. So what I'm going to do now is I filter out this one because it's the first between the two systems. I want to see what they're doing. This is pretty nice. You can filter from this conversation statistic and tell Wireshark to just filter that one communication, please, in both directions. I mean, the arrows on those things here are very, very small. You can hardly see them, but the top one is always give me both directions, going back and forth. So now I will filter that one. And now I have to wait again because I want it to go to the end. I cannot stop it in the meantime. Alright. And now I want to go to the end. You see here something is really going wrong. There's communication, some retransmissions, but at some point nothing is happening anymore. So here is suddenly the end of it. And I know that the trace is not at the end because it's going on and on. There's more traces than this after this one. I only brought two where you can see the problem. There's tons of traces after the second one that I merged into this, and you will never see the first communication again. It's just cut out in the middle of everything. No reset, no fin, no nothing. It just stops. And now I'm going to do something that I sometimes do too. I colorize the conversation. So I give it a color like this one. But I have colors turned off, so I don't see anything. Alright. So now it's in this kind of color, and now I clear the filter again, or go back to the IP filter that I have, because now I want to see where the second communication comes in. It should start right after the other one that's suddenly not doing anything anymore. And here you have, like, this is the last packet of the first communication. It ends with a retransmission and nothing else for hours and hours after this. It's just being open. No shutdown, no fin, no reset, no nothing. Neither from the embedded device nor from the server, for whatever reason. I don't know. I have no idea, to be honest with you. And what we see is just starting a new one. Just like, okay, this one doesn't seem to work. Okay, SYN, and let's go again. And that is the moment where the system, for a few seconds, I think there should be a time here that can tell you that there's a jump in here. I mean, I should probably put that on relative time. Where is it? Previous display capture. Yeah, you have here was the SYN. SYN is here. There's quite a long time where nothing happens anymore, and the cooling system thingy doesn't obviously know what's going to happen, and it cranks up the cooling system to the maximum. And it was a bit of annoying for me, because these guys, they couldn't give me any more than these traces. That was all they had. And I told them you need to capture on the device as closely as possible. I need to see what gets to the device, because this is on the server side. It's not on the device side, so I don't know what's happening in there. And they never got back to me. They were like, hey, what you found is pretty good. All right, let's be done with it. So I have no idea what actually gets to the device and what it's doing. So basically that is a case where I have to say, yeah, I saw that something is suddenly going wrong and is behaving very un-RFC-like, because it's not shutting down the communication like it's supposed to. And obviously there is some sort of problem, but it just keeps going with a new communication. And we verified that in a number of incidents where this happens all over again. It's always the same pattern. Suddenly the communication doesn't do anything anymore. It basically goes like to sleep or something, and it just starts a new communication. But in that moment the cooling system already is on 100% and doesn't come back down again for some reason. So that is where I usually say that these embedded devices are no fun at all to work with, because they're not doing what they're supposed to. They just work as much as the vendor needs for them to work under perfect conditions, and if there's not a perfect condition, well, they don't care. Looks like, yeah.
I think this sometimes when the programmer is not care about TCP things,
Yeah.
he had a timer. If the timer expires, then he make a new connection.
Yeah.
There's not what's going on there on their own connection.
That is something like this,
Yeah.
yeah. I can only guess, because I wasn't able to get any closer to either device, neither the server nor the embedded thing. But this is where it breaks. And well, it took me about a day to find this, because this is just a reduced amount of packets. It was a lot more. You know, they throw like half a terabyte at me at that point. See if you can find something. Get back to us in 5 minutes. No, I'm not. All right, so that was the second one. Now the third one is a very special one. Citrix. Who knows Citrix, or who is using it? Who has analyzed it? Who had fun doing it? You do? Okay. Well, the fun part for me analyzing Citrix is I have one large customer who calls me every time the Citrix systems do something wrong. And I had one occasion where I was walking into that bank, and the main administrator of Citrix saw me coming in, and he was like, "Oh no, not you again, go away, we don't want you here." And I was like, "Sorry, I'm here for a totally different problem, not Citrix this time." He was like, "Oh my god, thank you." Well, Citrix or RDP or VNC, all those remote desktop protocols are very difficult to analyze. They're no fun at all. If I have to do it, I do it, but it's taking a lot more time than it usually does for the other protocols. The scenario is a typical one. The users are using Citrix remote desktops on thin clients, and they're complaining about performance issues. It's always, of course, the network's fault. Must be, because it can't be anything else. And well, they had thin client devices, as I already said, and there was one session that froze for about a minute. Like the guy was doing something, and then the screen froze and couldn't do anything for a minute. Talking about ages or eternity in the network. If you're talking about seconds for interactive applications, that's too long. A minute is like somebody dropped a nuke on the network or on the application. So now I'm going to tell you why Citrix analysis is difficult. So if anybody is asking you if you could analyze Citrix, you should think about it first, because basic TCP knowledge will not be enough. First of all, the protocol they're using is not publicly documented. There is documentation, but you cannot get it unless you're giving them money, signing an NDA, and putting it into your product that you're going to sell. Products that do this are, for example, ClearSight and Sniffer Pro. I don't know, anybody using those? ClearSight, Sniffer Pro? All right. I looked at them, and well, I had to, because I needed to have a small chance of decoding what was happening in the session once, and I found out that both products are in the same area of not doing it completely right. ClearSight is doing something better than Sniffer, and Sniffer is doing something else better than ClearSight. Both are not good enough, and I wonder if they ever read the specifications correctly. Because even I can, with some public documentation, do better than what they are doing, at least in the way of ClearSight. Anyone here from ClearSight, the company? Good, okay. I will survive this one. I sent them bug reports, but they didn't do anything about it. So their decodes are pretty unreliable. I finally stopped using those because, first of all, they cost money, and second of all, their decodes are not good enough for me to be of any value, because if I have to question what the analyzer is telling me, that's not a good thing. I need to know that the analyzer is doing something right. Analyzing Citrix and Wireshark is therefore limited to, first of all, TCP behavior, and I will tell you why that is very difficult sometimes. And second of all, you can do some sort of decoding and verification on packet priority tagging. I don't know if you know this, but Citrix is priority tagging their packets that they're sending out. They have 4 traffic classes going from 0 to 3. 0 is like mouse interaction, something that needs to go out very fast, and 3 is like a print job or something that is that can take some time. That can be decoded if you know how, and I think I can try to find the specification for you. If you do Google for something like Citrix, this mouse is driving me crazy. Citrix ICA, what do I say? Priority packet tagging. There's one PDF at the Citrix Knowledge Center, and you can download it, and it will tell you that in the first byte of the TCP payload there is this priority tagging in there and how to decode it. So here's, it's pretty old, by the way, it's from 01. It will tell you high priority, medium, low, and so on, and how it's coded into this. There's some documentation here. It will tell you these bits are the priority bits, and you can basically, if you look at the hex dump, you can try to figure them out yourself. Wireshark doesn't decode these, but they could if somebody writes a decoder for it. And that is something that you could use to find out if a priority tagging is okay or not okay. We had one case that was years ago where Citrix for some reason suddenly tagged everything in prior class 3, in the worst class. Even the mouse and keyboard interaction was tagged as prior 3. And the performance went to hell, basically, because the packet shapers they had thought, well, it's the most important traffic class, I'm not pushing it through fast. So we did an analysis once where we used this kind of information, and the fun thing about this was that Citrix started to argue with our findings. They said, are you sure that you do it right, that you decode it the right way? And I was like, well guys, I've got the PDF from your site. In there it tells me that this is what you do. You should read it probably. Because obviously they hadn't. Yeah? And then there was this funny thing where the customer at some point told me, now it's better. Okay, what did you do? Well, Citrix had a new release, and they said it had nothing to do with the priority class, but now it's working. I was like, yeah, that's the typical thing. So we did a capture again, and we saw now it's tagged correctly. But they didn't do anything to it. Of course not. Okay, so that is one thing that you can do. The other thing that you need to do is look at TCP behavior. How much time do I have left? 10 minutes, okay. What's so bad about TCP behavior when you're talking about Citrix? Who can tell me that? What's the problem with TCP behavior? Small packets? Yeah, it's small packets, so you have a high chance that a medium-sized trace file will already crash Wireshark because there's so many of them in there. Yeah, but the biggest problem that you have is usually we're used to TCP being sort of a request-response protocol. So you go like HTTP GET, give me this, and then you can tell is the server answering quickly or not. So if you get a file back from the server and it's coming back fast, you say this is good. If it's coming back after a long time, you say, well, something is not so good right here. You can't do that with Citrix because the server can at any point in time send you data because it's like, oh, here the Windows was popping up, I need to tell the user about it, and it will send me asynchronously data back to me without me requesting it. So what I can't do is like look for long delta times, because long delta times will not be any help at all. Now they could be perfectly fine because the server didn't have anything to tell me, and suddenly I get something from the server the user didn't request. And if I go for long delta times and say, this is a problem, I cannot decode it, I cannot tell you if it's really a problem or not, so that is very, very difficult. So doing this is always a fun thing, because you need to guess if a packet should have been answered quickly or not. What I usually do is by looking at how big the packets are and if it's something that the server sent out of order or unrequested or not, but you can be wrong a lot of times. Okay, let's take a look at this one. Well, keep in mind there was this user saying he froze for a minute. Where's my Wireshark? No, I don't need this one. Go away. I closed it, I think. Okay. Go back to the traces. All right. So now let's show this one in my other profile, because I know it's small, but I have color coding in there that is quite impressive sometimes. You don't need to read these packets, even if they're small. The color will tell you that there's nothing wrong right now. And at some point, if I scroll long enough, something will happen, maybe. Well, I don't care. I use my button is gone because I changed my profile. Now I have to type again. Too bad. TCP analysis flags. Now you can see I'm using colors to show me stuff that is not exactly normal. So the more red there's in there, the worse it is. So if it's yellow, it's like, could be a problem. If it's red, not good. So here's some stuff like window full, window full, window full. Yeah. And zero window, somewhere here. That's not completely red, because zero window is not completely critical if it recovers quickly enough. Okay, so now I'll go back to the other profile that you can read the packets. Okay, so now TCP analysis flags wasn't applied right away. That is a problem that you have if you're switching profiles sometimes, that it doesn't right away apply the filter. So zero window, this one here. Yeah, is that a problem? Do you think zero window is a problem? So usually if I ask a question like this, my students in my classes learn that the correct answer is, it depends. And the bad thing about that is, as soon as they learn that and they are answering me, each time when I ask them something, it depends, my next question is, okay, on what? And then it's like, I don't know. You want to say something, Hansa?
No, just the updates.
Yeah, the updates, let's say I filter on this one here, conversation filter TCP. And we'll take a look at the updates. What is a window update? It basically means that a system tells the other, my window size has changed. There are some window updates that are completely uninteresting, because sometimes the system will tell you, I had 62K, now I have 64K, and you're like, this is great. But sometimes, like in this case, you will see like zero window, like, oh, I don't have any buffers left. What happened to my, I need to make this, oh, come on. Here you can see Windows 0, and here it comes back up to 7,405. The question always is, how long did it take to get back up? It's okay if it's 0. If it recovers quickly enough, it will not even slow down the communication much. So we will take a look and we will see it's 2 milliseconds. Well, that's not great, but it's not critical at all either. If I'm looking for a delay of about a minute, this is like, I don't care. It's too small. And if I keep looking through the things, I will see that here's a 0 window again. And even if I go here, you will see it recovers quite quickly. So now the question is, where's all the time going to? And what I tried here, and that was just for fun, I was going to use a filter like frame time delta greater than 10 seconds. Remember that time in Citrix is sometimes not giving you anything, but in here I just tried it for the fun of it, because I knew I was looking for a minute of delay, so I tried 10 seconds for a number. And I got a lot of stuff here. It tells me 20, 20, 20, 20. Quite close to each other. So I said, well, yeah, that doesn't look too specific enough. Let's go higher. What do you think will happen if I go for 20? Will I see all the packets again? Yeah, because the number seems to be greater than 20, so if I do 20 again, probably I will see all of them again. Now watch this. I don't. The reason for this is the timing is based on what you see in the decode. Yeah, so you saw the 20 seconds to the previous packet, but there were packets in between, and I'm not filtering on time delta displayed, I'm filtering on delta. So now this is something where I said, well, this packet has a time difference, this looks strange here, that's more than 20 seconds. It says 0 here because it's the first packet that I see, and time displayed, delta time displayed will only show me the time difference between the display packets. So now I go here and I filter on this one and say, well, if there's a time delta before this one that has 20 seconds, maybe that's the point where it really gets bad. And if you look at this, this is the last packet. Suddenly I have this here, and now I have a window full, 0 window, and let's put a time reference here to find out. I don't care. Go ahead, do it. Now you'll see that the window update takes 60 seconds. So this client, this is a client here, you can't read it because it's the funny migraine colors. The client is basically telling the server, don't send me anything, don't send me anything, don't send me anything, don't send me anything, for a minute.
We didn't see that when you said greater than 20.
How we could see that?
When you said greater than 20, you didn't see that 60.
The 60 is now because I toggled the time display to absolute from the time reference. So it's counting up from 0, where the red is, that is my new 0, and it will add up the times down here, and it's in addition, or adding them all up gives me 60. That was this small dialog where it asked, do you want to change the timing to relative times? And I did that. So this is what it is. This is the 60-second delay. And of course it was blamed on the network, like the network is slow. But if you see something like this, like a 0 window phenomenon that is going on for a minute, it's like, dude, your hardware is like not good enough. So they are having thin clients they rolled out 4 or 5 years ago. And what happens basically is that the users started to not only use like Excel and Word on them, where there's little data coming to the thin clients, but of course users are using like Flash Player and stuff like that with tons of screen updates, and it's basically overloading the thin client hardware that is not powerful enough for that new media stuff that is going around the office now. So basically what they need to do is they need to replace their clients for faster machines. That is the one thing that they have to do. So this is basically a client that says, I'm too slow. And this was quite easy to find. I mean, it was, once again, it was, I think, a capture of millions of frames. So I broke it down to a manageable size for this presentation. But it took me, I think, 2 or 3 days to get to this. So this was just like a fast track. All right, still if somebody asks you to do Citrix analysis, you should be careful, because it will challenge you quite a lot, because sometimes it's not as obvious as this one. Yeah? Sometimes it's really hard to find. Okay, so what's my time? I have to be done, right? Okay. How much cases did I do? 3. I have another one. I'll probably go, since I'm doing this talk again on Wednesday, I'll probably switch out one of the things that I already showed and do the 4th one on Wednesday then. So if somebody is, well, actually liking this talk good enough to come back to me, I will show something different. Yeah, but you have to live through 2 other cases that you've already seen. And maybe I do them completely different, I don't know, because I don't have a script, I just do them like this. All right, thank you.